All right, for this problem, we are asked to find the points on this curve, xy squared equals 16, that are closest to the origin. So for this problem, we can use the method of Lagrange multipliers if we imagine the origin as being the center of a sphere that's expanding, and it's going to expand until it hits our curve. And so our f of x, our function, our f of xy, is going to be equal to that sphere centered at the origin, which is going to be x squared plus y squared. So as that sphere expands, then this radius would get larger and larger until we bump into our curve. So this is our constraint, and this is our function. So we're trying to find the extreme values of this function subject to this constraint. All right, and we can use Lagrange multipliers, which says that the gradient of f has got to be equal to the gradient of g, and we're going to define g of xy to be this set equal to 0. So xy squared minus 16. So gradient of f is equal to the gradient of g times some constant lambda. All right, and also g of xy has got to be equal to 0. So first, let's find the gradient of f, which is going to be the partial derivative of f with respect to x, which is 2x, times our unit vector I, plus the partial derivative with respect to y, which is 2y, times the unit vector j. All right, next, the gradient of g is going to be the partial derivative with respect to x, which would just be y squared, plus the partial derivative with respect to y is going to be 2xy times j. And now we know that gradient of f has got to be equal to the gradient of g times lambda. So each of these components, we take 2x, that's got to be equal to y squared times lambda. And 2y has got to be equal to 2xy times lambda. All right, so let's, if we take this one first, let me erase this for a moment. If we just take this equation, divide both sides by y squared, we're going to get that lambda is equal to 2x divided by y squared. And the other one we said was 2y is equal to 2xy times lambda. If we divide both sides by 2xy, we're going to get that lambda is equal to, if we divide 2y by 2xy, we're going to get 1 over x. So now we've got lambda is equal to 2x over y squared, and lambda is equal to 1 over x. So let's set those equal to each other. So 2x over y squared has got to equal 1 over x. So let's do a little algebra here. We're going to get that 2x squared is equal to y squared. And now let's go back up to our constraint here, xy squared is equal to 16. So here we have y squared is equal to 2xy. So let's replace that y squared with 2x squared. So x times 2x squared has got to equal 16, which is going to mean that 2x cubed is equal to 16, so x is going to be equal to 2. If we divide both sides by 2, we get x cubed equals 8. So x is 2. All right, now let's take that 2 and plug that in here. We're going to get that 2 times y squared is equal to 16. If we divide both sides by 2 there, we get y squared is equal to 8. So y is equal to plus or minus the square root of 8, which is 2 root 2. And so now our points that are going to be closest to the origin are going to be the points 2 and then either positive or negative 2 root 2. And that's going to be our answer.